Hey everyone, it's Berm, and this is Level 0 Networking. In this lab, we're going to create a dynamic multipoint solution using ZeroTier and VyOS. When you think dynamic multipoint, you're probably thinking about Cisco DMVPN, maybe ADVPN, something of that nature. However, this solution is easily accessible and able to be used on any platform running FRR, so pretty much most Linux platforms. We're going to be using VyOS. Before we go into that though, we should go over what is ZeroTier. ZeroTier's website says ZeroTier lets you build modern, secure, multi-point virtualized networks of almost any type, from robust peer-to-peer networking to multi-cloud mesh infrastructure. We enable global connectivity with the simplicity of a local network. Again, you can use any distro that allows you to install FRR. However, we're fans of VyOS, so that's what we're going to use. In this lab, we're going to be using VyOS version 1.4 RC3. In the blog post, you'll notice it uses RC1. However, there's some updates and bug fixes in RC3, and so that's what we're going to be going with in this lab. To get started, we'll go ahead and hop into the system. The default username and password are both VyOS. Then we want to go ahead and install the software. To do this, we're going to use install image. The reason we're going to do this is so that it'll be persistent. When you reboot the system, you don't have to worry about reinstalling again. We're going to accept all the defaults for this. And once this is done, we're going to end up setting the external interface for DHCP. We'll also be setting the DNS so that we can get to the website to install ZeroTier. Now that the image is installed, we're going to want to reboot it. The reason for this reboot is so that when it comes back up, any configuration changes we make are going to be persistent. All right, now that that's complete, let's go ahead and configure the interface. First thing we need to do is log into configuration mode. Now that we're in configuration mode, we'll set the interface. After that, we'll commit our changes, exit. We'll do a show IP route to make sure the route exists. There it is, we see 0.0.0.0. Next, we'll ping www.google.com just to verify that we do have internet connectivity, and we do. Let's stop that. We're going to have to stop it on all of our devices. To utilize ZeroTier, we're also going to need to create an account. To do that, we go to my.zerotier.com. Once you get here, you just go to the login/signup button, and you can log in with Google, GitHub, Microsoft, or you can sign up with a new account. I'm going to be logging in with an account I created previously. Once we get logged in, if there isn't a network already created, you can go ahead and click Create Network. We'll go ahead and use the one that's already existing, and you scroll down to Advanced. You'll notice under Advanced, there's already a managed route and an IP range assigned. You can use any one of these IP ranges right here, and it will automatically assign to the nodes that you join. For the purposes of this lab, I'm going to click Advanced, and I'm going to add my own range. We're going to do 10.13.0.0 to 10.13.255 to 255. We'll submit that. We will delete the already populated one. We'll also delete this managed route and add my managed route of 10.13.0.0/16. Submit. And now we are good to go. You're going to want to annotate this network ID. It's going to be used to join your devices to the ZeroTier network. Next, we'll go into the shell. To do that, we do sudo su, that's switch user. And then we're going to curl to ZeroTier's website, which will install the ZeroTier software. One good thing about using ZeroTier is going to be the scalability. Once you get this configured, you can pretty much go through and just duplicate it over and over again for different sites. Ease of use with this software is definitely there. Highly recommend using this. All right, now that that's done, what we're going to end up doing is we're going to go into the ZeroTier 1 folder. We're going to create a file called device map, and then we're going to bind the network ID to an interface. We'll go ahead and do that now. Once you do this, make sure there's been a carriage return, and then you hit Control-C to get out of the file. We'll go to all our devices and do that, and then head back over to the hub. I've been putting in all the configurations at once using secure CRT and sending commands to all sessions. Now we'll go ahead and restart the ZeroTier service, and we'll go ahead and join the network. As you can see, we got a 200 join, okay. When we come back to the ZeroTier website, you'll notice that there are now 3 members. We have my hub, spoke 1, and spoke 2. You'll have your physical IP address, and you'll have your managed IPs. I don't currently have any managed IPs in mine, so I'll go ahead and add IP addresses that I want now. Spoke 1 was EF2, so I'm going to make that 10.13.0.2. And finally, I'll make spoke 2 10.13.0.3. Also, just so everyone is aware, by the time this video is posted, this network will have been deleted. So now that we have our managed IPs, we'll click add on all those, and we'll go ahead and authorize the devices. Now that these are authorized, we'll go back to the CLI and verify that we have an IP address on Ethernet 10. So in the CLI, we'll go ahead and do show interfaces. And as you can see, Ethernet 10 has 10.13.0.1, just as we had assigned inside of ZeroTier Central. Now, when deciding to do routing, we have a few options that we can go with. ZeroTier has a managed route section where you can add static routes to get to each network. This isn't really dynamic though, and it doesn't allow for any health checks. So even if the path isn't available, the route is still going to exist, essentially not allowing your traffic to go. This also doesn't allow for equal cost multipath. The other options are EIGRP, ISIS, OSPF, RIP. The problem with these solutions is that they're going to build a full mesh between all the nodes. In a small environment, not a big deal, but once you start scaling up, it starts to get pretty messy. In this lab, we're actually going to be utilizing BGP, iBGP exactly, and we're going to use route reflection since it will already have the next hop unchanged as a default behavior. That is going to allow for dynamic spoke-to-spoke communication. So back on the hub, we're going to go ahead and change this so I'm only sending commands to the active session. I'm going to paste a bunch of commands in and then we'll go over those commands. This is going to allow the other spokes to dynamically peer with the hub. As you can see in the IPv4 unicast section, we've got our route reflector client, and then we have our IPv4 unicast network. This would be if we were going to have a network behind the hub that we wanted to advertise. So we'll go ahead and input these commands. Oh yes, let's go back to VyOS, go into the configure mode, and now we'll input these commands. Next, we're going to have to configure the interface. And then we'll go ahead and commit this configuration. Next, we'll go to the spoke, and we're going to do the same thing. On the spoke, however, we're not going to have the BGP listener, and we're not going to have a route reflector client. So in this configuration, we're just setting our AS and the remote AS to be the same. We're doing an IPv4 unicast, the next hop self, and then we're also setting our network address. So it's going to be 10.0.11.0. That's going to be our LAN address. Again, the same thing. So exit, and then go into configure, and then put the commands in. Next, we're going to set our interface, and we will commit this config as well. Finally, we're going to move to spoke 2. Spoke 2's configuration is going to look very similar to spoke 1's configuration. And again, we'll exit, and then go into configure, and then we'll paste the configs in. This is a very scalable way to do this. If you want the configs to be identical and you want to do a redistribute connected, you can go check out the blog, which I'll have posted in the description, and there's an example of how to set that up as well. I did just notice that we need to add the interface as well after we do that commit. We'll go ahead and add the interface. We'll commit one more time. Next, we'll go back to the hub. If we do a show IP BGP sum, we should see that we have 2 neighbors. Again, let's leave exit mode, show IP BGP sum, and we have both of our neighbors. Now we'll head over to spoke 1. Now, if we look at the ARP table, we'll notice that we only have one ARP entry for the 10.13. Also, if we look at ZeroTier CLI, we'll notice that we don't have a direct path to spoke 2. To do that, we do sudo ZeroTier-CLI peers, adding the sudo from the VyOS that allows us to run commands inside of the Linux shell. From spoke 1, we should be able to ping to the 10.0.12.1 address from 10.0.11.1. And as you can see, it does ping. The first ping will have a slightly higher latency due to the fact that it has to resolve ARP before it's able to ping. Well, that's it for this lab. There will be a part 2 where we add multi-tenancy to the solution using MPLS. If you haven't already, make sure you stop by the blog. I'll put the link in the description below. And like and subscribe to keep up with future videos.